Number bonds are an integral part of early mathematics that impacts the children's understanding and ability to do mathematics throughout the school. It begins in reception, where the children learn their number bonds to 5, and then it carries on into year 1 and beyond, and they're applied then throughout all of the year groups. So they're an essential part of children's journey in progressing in maths. So looking at number bonds to 5 here, the children might have a representation like this using tens frames to show all the number bonds to 5, and then they would be able to state what 5 is made up of. So here you could see 5 is made up of 5 and 0, and then you would say 5 and 0 make 5. Or in this one, 5 is made up of 1 and 4, 1 and 4 make 5. And from this, once the children were able to recognise all the number bonds to 5 and what 5 is made up of, then they could talk about how you can partition that whole number of 5. So we would use a part-whole diagram to help us. The whole is 5, and 5 could be partitioned into 5 and 0, just like our first example shows. And then 5 could also be partitioned into 1 as being the part and 4 being the part, and so on. They would carry on being able to do that. Once the children were able to talk about how you can partition 5 into those two parts, then they're ready to build a addition equation. So children in year 1, this would be when they start to write addition equations, will be able to then write 5 plus 0, so knowing that the two parts added together to make the whole of 5. So you can see that's started here in this representation, then it's moved into partitioning, and then it's shown here in the addition equation. And then 1 plus 4 equals 5. The progression from this to this and to this. So the children's understanding of number bonds to 5 is extremely important, because then they're able to work out other things that they know. So, for instance, if they had the equation when they're older, moving into later in year 1, and then also in year 2, if they had an equation like this, 11 plus 4 is equal to, they could utilise their knowledge of 1 plus 4 is equal to 5 to help them to be able to answer this very quickly. So they know they've got the 10, and they know that 1 plus 4 is equal to 5. So 11 plus 4 must be equal to 15. The children need to learn all of their number bonds to 10. Sometimes that can be confused with just learning number bonds to 10, but I mean not all of them all the way up. So they need to learn the number bonds to 1, to 2, to 3, to 4, to 5, to 6, to 7, to 8, to 9, and to 10. Because this will enable them to apply it to bigger numbers as they progress throughout the school and be able to answer really quickly, because they can use their number fact knowledge to help them. So this is just an example of number bonds to 7, and it follows that same process I talked about with number bonds to 5. First, they would look at recognising all the number bonds and learning them. So knowing 7 plus 0 equals 7, 1 plus 6 equals 7, 2 plus 5 equals 7, 3 plus 4 equals 7, 4 plus 3 equals 7. And in this one, they're starting to see that, and it's reinforcing what they would have learnt about addition, that the parts can be added in any order and it still equals the same whole. Then we have 5 plus 2, and then we have 7 plus 0. Then they're able to partition it. So looking at that first one, we have the whole of 7. It can be partitioned into 0 plus 7. Those are the two parts. So that's that one. And the second one, the whole of 7, can be partitioned into 1 and 6. Then they move on to the addition equations of 0 plus 7 equals 7. So knowing those parts can be added together to make that whole of 7. 1 plus 6 equals 7. And then, as I showed you before, it would mean that they would be able to answer number equations with bigger numbers with automaticity, so doing it much quicker because they're able to use their number facts. So say if we looked at this number fact here, 3 plus 4 equals 7. So if I know that 3 plus 4 equals 7, then I know that 13 plus 4 must equal 17, or 23 plus 4 must equal 27, and so on. Once we've learnt all our number bonds to 10, so all the way from 1 up to 10, we can also use them to help us with subtraction. So, for instance, if I take this number fact here, so this number fact is 6 plus 4 equals 10, or is equal to 10, then I can use that, using my understanding of addition and subtraction, to come up with the corresponding subtraction fact. So if I draw a part whole, you'll see what I mean. So I know the whole is 10. I know that the parts I'm adding are 6 and 4. So then I can use that to help me to come up with a subtraction fact. I know when I'm doing subtraction that I am always minusing from the whole. So I have 10 minus, and then I can use my knowledge that I can minus the part of 6, and it's going to leave me with the part of 4, because if we add those together, that's what makes 10. So 10 minus the 6 is equal to the 4. I'll show you another example. So if we take this addition fact here, the number bond, so now we have 9 plus 1 is equal to 10, and I can again show it in the part whole diagram, which really helps the children to be flexible with number. So I can see from this part whole diagram, I've got the part of 9 and 1. If I add them and combine them, it makes 10. So I can use it as a subtraction fact. I've got my whole of 10, always minus from the whole, and I'm going to take away the 9, and I know that it will be left with the 1. The children will do lots of work on this practically to understand this concept, but this is what they're building toward, to be able to use their facts, to quickly be able to link them to other facts and be able to answer things that are harder in bigger numbers as they progress throughout school. And it would also sort of the same thing. So if I know that 9 plus 1 equals 10, then I know 19 plus 1 would equal to 20. And if I know that 10 minus 9 equals 1, then I would know that 20 minus 9 would equal 11.